today's topic are trigonometry and applications. That is heights and distances. So, to start with, let us start with trigonometric ratios. Trigonometric ratios. We very well know the trigonometric ratios are, we are very much familiar with sin theta, cos theta, tan theta, and their reciprocals, cosec theta, sec theta, and cot theta. I hope all of you know these ratios, the trigonometric ratios. Sin theta, cos theta, tan theta, cosec theta, sec theta, and tan theta. Come to the angles. We have, if theta is equal to 0 degree, then sin 0 will be equal to 0, cos 0 will be 1, tan 0 will be equal to 0. Similarly, cosec 0 will be 0, will be not defined, and cos 0, sec 0 will be equal to 1, then tan 0 is 0, so cot 0 will be n. If theta is equal to 30 degree, then sin 30 is equal to how much? 1 by 2. Cos 30 degree is equal to root 3 by 2. Tan 30 degree is equal to 1 by root 3. Same way, you can have other three ratios of 30 degree, that is cosec 30 degree, to the sec 30 degree, 2 upon root 3, and cot 30 degree. This is for angle 30 degree. Same way, you will have if theta equal to 60 degree. In this case, sin 60 degree will be equal to root 3 by 2, cos 60 degree is equal to 1 by 2, and tan 60 degree is equal to root 3. And similarly, you can go for its reciprocals. Again, if theta equal to 45 degree, then I hope you know the values of sin 45. Sin 45 degree is equal to 1 by cos 45 degree, 1 by root 2 again, and tan 45 degree is equal to 1. And if theta is equal to 90 degree, then what is sin 90 degree? Is equal to 1. Cos 90 degree will be 0, and then tan 90 degree is not defined. Similarly, you can find out the other ratios. Let's have a question. If 2 sin theta is equal to root 3. Question for you. 2 sin 2 theta equal to root 3. Then theta equal to how much? Can you find out? Yes. From this, we get sin 2 theta is equal to root 3 by 2. So that implies sin 2 theta is equal to sin 60 degree. Because sin 60 degree is equal to root 3 by 2. So that implies 2 theta is equal to 60 degree or theta is equal to 30. So we get theta is equal to 30 degree. In the same way, you can have one more question. Root 3 tan 2 theta minus 3 equal to 0. So similarly, as we did, in the similar manner, you can attempt this question also. So you get root 3 tan 2 theta is equal to 3. Tan 2 theta will be equal to root 3, and then that implies tan 2 theta is equal to tan 60 degree. And that, because tan 60 degree is equal to root 3, so that implies 2 theta is equal to 60 or theta is equal to 30. In this case also, theta is 30 degree. So these are few values which you must know for the known angles: 0, 30 degree, 45 degree, 60 degree, and 90 degree. What is value of sin 45 degree? Let's find out the value of sin 75 degree. How can you get it? You remember we have done it. It is equal to sin 45 degree plus 30 degree. And we know the formula. This is equal to sin 45 degree plus sin 30 degree. Plus cos 45 degree sin 30 degree. So that is equal to 1 upon root 2 into root 3 by 2 plus 1 upon root 2 into 1 by 2. So that is equal to root 3 plus 1 on 2 root 3. Further, if you rationalize, is the value. So we are using the formula sin A plus B is equal to sin A cos B plus cos A sin B. Similarly, we have formula for cos A plus B is equal to cos A cos B minus sin A sin B. Then we can also derive the formula for tan A plus B as tan A plus tan B upon 1 minus tan A tan B. These are the values for sin, cos, and tan for the angle A plus B, sum of the angles. Let's have the values of sin, cos, tan for the difference of the angles sin A minus B is equal to sin A cos B minus cos A sin B. Cos A minus B, cos A cos B plus sin A sin B. That tan A minus B is tan A minus tan B by 1 plus tan A tan B. You know the These are the formulae for the difference of the angles. Now, knowing the sum of the angles, we can get the formula for sin 2a. If we replace this b by a, it becomes sin a plus a, and we get sin 2a. Okay? Let's get the formula for sin 2a. So sin 2a is equal to sin a plus a, that is equal to sin a cos a plus cos a sin a, that is equal to 2 sin a cos a. So we get sin 2a is equal to 2 sin a cos a. Similarly, you can go for the formula cos 2a. Cos 2a. This sin 2a in terms of sin a and cos a is 2 sin a cos a. In terms of tan, it is 2 tan a upon 1 plus tan square a. Cos 2a, in the similar manner, cos 2a, if you replace b by a here again in the formula cos a plus b, you get cos square a minus sin square a. Cos square a minus sin square a. Further, this will be equal to 2 cos square a minus 1. If you convert sin square a in terms of cos, then this is also equal to 1 minus 2 sin square a. And in terms of tan, it is equal to 1 minus tan square a by 1 plus tan square a. These are the values for cos 2a. Cos 2a will be equal to cos square a minus sin square a. As we did, it is also equal to, we can convert it into cos. Totally cos, it is 2 cos square a minus 1. In terms of sin, it is 1 minus 2 sin square a. And in terms of tan, the same cos 2a is equal to 1 minus tan square a upon 1 plus tan square a. In the same way, we can find out tan. Tan of a plus b. So replace b by a, we get tan a plus a, 2a, is equal to 2 tan a by 1 minus tan square a. That is, we have replaced a by b. So tan a plus a is equal to tan a plus tan a by 1 minus tan a into tan a. So we get 2 tan a upon 1 minus tan square a. So this is how we get the values of 2a, sin 2a, cos 2a, and tan 2a. Tan 2a in terms of tan, cos 2a in terms of tan, sin 2a in terms of tan. Then, in the same way, we can get the values of 3a. The formula for sin 3a is equal to 3 sin a minus 4 sin cube a. If you remember, the formula for cos 3a, will be 4 cos cube a minus 3 cos a. And tan 3a will be equal to 3 tan a minus tan cube a by 1 minus 3 tan square a. Tan 3a is equal to 3 tan a minus tan cube a by 1 minus 3 tan square a. Let's start. And tan, what will be tan a plus b plus c? Tan a plus b plus c is equal to tan a plus tan b plus tan c minus tan a tan b tan c upon 1 minus tan a tan b minus tan b tan c minus tan c tan a. This gives you the formula for tan of a plus b plus c. Now, let's have some multiples of the angles. Sine of a plus b into sine of a minus b. What will be the value? Sine of a plus b into sine of a minus b. Sine of a plus b is equal to sine a cos b plus cos a sine b into sine of a minus b is sine a cos b minus cos a sine b. So this will be equal to sine a cos b a plus b x plus y into x minus y, which is x square minus y square. This becomes sine square a cos square b minus cos square a sine square b. This is what we get. Sine square a cos square b minus cos square a sine square b. So if we convert this cos square b in terms of sine, so you get sine square a into 1 minus sine square b minus this also you convert into sine 1 minus sine square a into sine square b. Simplify further, you get sine square a minus sine square a sine square b minus sine square b plus sine square a sine square b. So we find that these two get cancelled, and that is equal to sine square a minus sine square b. Thus we get sine of a plus b into sine of a minus b is equal to sine square a minus sine square b. What if you convert sine square a in terms of cos, and here also sine square b in terms of cos? You get the value in terms of cos. So to get it in cos, to get the result in terms of cos, again, sine of a plus b into sine of a minus b will be equal to, again, you got sine square a cos square b minus cos square a sine square b. So here, if we want to get the result in terms of cos, you need to change the identity sine square and sine square in terms of cos. This will become 1 minus cos square a into cos square b minus cos square a into 1 minus cos square A plus cos square A cos square B. So here you can observe these two get cancelled and the result is cos square B minus cos square A. So that's the same sin A plus B into sin A minus B in terms of sin A, sin square A minus sin square B, and in terms of cos, it is cos square B minus cos square A. Similarly, cos of A plus B into cos of A minus B will be equal to cos square A minus sin square B. Cos of A plus B into cos of A minus B is equal to cos square A minus sin square B, or it is equal to cos square B minus sin square A. Anyways, it depends upon the conversion. So we got the values for sin A plus B into cos sin A minus B and cos A plus B into cos A minus B. What if we are going to add these two? Here we have multiplied. Let's add sin of A plus B plus sin of A minus B. What will you get? We add the results of these two. So here again we get sin A cos B plus cos A sin B plus sin A cos B minus cos A sin B. So here this and this gets cancelled, then we are left with 2 sin A cos B. Thus, the addition of these two results is 2 sin A cos B. Similarly, cos A plus B plus cos A minus B. Can you tell me what will be the result? This is 2 sin A cos B. Then same way you can go for this. This is equal to cos A cos B minus sin A sin B plus cos A cos B plus sin A sin B. So we get these two gets cancelled and the result is 2 cos A cos B. So cos A plus B plus cos A minus B will be equal to 2 cos A cos B. So similarly, sin A plus B minus sin A minus B. Sin A plus B minus sin A minus B. Same way, sin A plus B is that and sin A minus B is this result. Okay. So in this case we are subtracting. So these two get cancelled and we are left with 2 cos A sin B. Similarly for this, cos A plus B minus cos A minus B diagram, that will be, we are subtracting, here we have added. So adding, we get this plus this, subtracting, we get this minus and this also minus. So we get, these two get cancelled, so you will be left with 2 cos A sin B. 2 sin A sin B. It will be minus 2 sin A sin B. You want it to be expanded, or you can just look here. same cos A plus B will be this. Here comes minus. Cos A minus B is cos A cos B plus sin A sin B. So both of these becomes minus. So these two get cancelled. Then you are left with minus sin A sin B minus sin A sin B, that is minus 2 sin A sin B. Or you can write this as cos A minus B minus cos A plus B is equal to 2 sin A sin B. So we got the sum, the differences, and the products of A plus B and A minus B, trigonometric ratios of A plus B and A minus B. Let us have the values for the negative angles. Theta is equal to minus x. Then sine of minus x will be equal to minus sin x. Cos minus x is equal to cos x. And tan minus x is equal to minus tan x. Then same way we can get the values of minus x for cosec minus x, sec minus x, and cot minus x. Then coming to complementary angles. This you must remember. Complementary angles. (90 minus theta). Sine of 90 minus theta is equal to cos theta. Cos 90 minus theta, sin theta. Tan 90 minus theta, cot theta, and vice versa. Cos 90 minus theta will be sin theta, sin 90 minus theta will be cos theta, and cos 90 minus theta will be tan theta. In the same way, you can go for 90 plus theta angle. So you get sin 90 plus theta will be equal to cos theta, and this is in second quadrant. Sin 90 plus theta will be equal to cos theta. Then cos 90 plus theta, cos 90 plus theta will be equal to minus sin theta. Then tan 90 plus theta will be equal to minus cot theta. And in the same way, you can get the values for cos 90 plus theta, then sin 90 plus, and then cot. That's in the reverse way. Then coming to 180 minus theta. Let's have the trigonometric values for 180 minus theta, angle 180 minus theta. Sine of 180 minus theta will be equal to sin theta. Sin 180 minus theta equal to sin theta. Cos 180 minus theta is equal to minus cos theta. And then tan of 180 minus theta will be equal to minus tan theta. The same way you can have for 180 plus theta. What will be the value for sine? Sine of 180 plus theta is equal to minus sin theta. Cos of 180 plus theta will be equal to minus cos theta. and tan of 180 plus theta will be equal to tan theta. So thus you can find out the various trigonometric ratios with these angles. Then let's come to the identities. To remember the identities, trigonometric identities. First identity, sin square theta plus cos square theta is equal to 1, which gives you further results as 1 minus sin square theta is equal to cos square theta. 1 minus cos square theta is equal to sin square theta. Similarly, the second one result is sec square theta minus tan square theta is equal to 1. From there, we get the further result as sec square theta minus 1 is equal to tan square theta. And another one is 1 plus tan square theta is equal to sec square theta. Third identity, cosec square theta minus cos square theta is equal to 1. From this, you get cosec square theta minus 1 equal to cos square theta, and then 1 plus cos square theta is equal to cosec square theta. So these identities you must know, and their conversions also you must know. Let's solve some questions. Find the value of sin 24 degree plus sin 32 degree plus sin 204 degree plus sin 212 degree. Now if you see, these angles are so big, and these are unknown angles. So for this, sin 24 plus sin 32 plus, now we can get this 204 degree in terms of 24 or 32. So this you can write as sin of 180 plus 24. We get 204 degree plus, again 212. We can write as sin of 180 plus 30. Then, as we have learned just now, sin 24 plus sin 32 plus sin 180 plus theta is minus sin theta. So it becomes minus sin 24, then minus sin 32. This is equal to 0. In the same way, let's find out the value of sin 35, sin 55. Value of sin 35, sin 55 minus cos 35, cos 55. How to get the value? Here, we can write this as sin 35 into sin 55 you can convert by the complementary angles, using complementary angles. This will be cos 35 minus, here again this is cos 35 degree into this will be sin 35 degree. We convert this. This is equal to 0. Let us find out one more question. Find the value of A if sec phi A is equal to cosec A plus 36. Sec phi A is equal to cosec A plus 36. Now, how to proceed for the solution? For this, we must know, again, come back to the complementary angles. We know sec and cosec are complements. Okay, so sec we can convert to cosec. So this will be cosec 90 minus phi A. Cosec 90 minus phi A is sec phi A is equal to cosec A plus 36. So we get that implies 90 minus phi A is equal to A plus 36, or 90 minus 36 is equal to 6A. So we get 90 minus 36 equal to 6A, or 6A is equal to 54. So that implies A is equal to 9. So the value of A is 9. Now let's have some results in trigonometry what we have learned. The first result, very important result, if sec theta plus tan theta is equal to P, then sin theta is equal to how much? Do you remember? If sec theta plus tan theta equal to P, then sin theta will be equal to, if you remember, it is equal to P square minus 1, P square plus 1. Second result, important result, if cos theta plus sin theta is equal to root 2 cos theta, then what will be cos theta minus sin theta? If cos theta plus sin theta equal to root 2 cos theta, then the value of cos theta minus sin theta will be equal to root 2 sin theta. You need to remember, we have already worked out this one previously. Now we are recollecting. Further, the next result, if x is equal to r sin A cos c, r sin A cos c, y is equal to r sin A sin c, and z is equal to r cos A, then x square plus y square plus z square will be equal to r square. If you remember this, if you want to work out, you can work it out. X square is equal to r square sin square A cos square C. Y square is equal to r square sin what do you get? X square plus y square plus z square is equal to r square sin square a cos square c plus r square sin square a sin square c plus r square cos square a. So this is equal to, in these two if you see, you get r square sin square a common. You are left with cos square c plus sin square c plus r square cos square a. Now cos square c plus sin square c is 1, so we get r square sin square a into 1, you see, plus r square cos square a. So here again r square is common and we have sin square a plus cos square a in bracket. So that is equal to r square into 1 equal to r square. So this we get x square plus y square plus z square is equal to r square. Then further, next result. If m is equal to a cos theta plus b sin theta and n is equal to a sin theta minus b cos theta. If m is equal to a cos theta plus b sin theta and n is equal to a sin theta minus b cos theta, then a square plus b square will be equal to m square plus n square. This also, if you square it on both the sides and add them, will come to this result. A square plus b square is equal to m square plus n square. Another result, if a cos theta minus b sin theta is equal to c. If a cos theta minus b sin theta equal to c, then a sin theta plus b cos theta will be equal to how much? If a cos theta minus b sin theta equal to c, then a sin theta plus b cos theta will be equal to how much? So this will be equal to plus or minus under root a square plus b square minus c square. If you remember, we have already proved it. A cos theta minus b sin theta equal to c, square it both sides and then proceed. You will get a sin theta plus b cos theta is equal to plus or minus under root a square plus b square minus c. Further, another important result what we have already seen is if sin theta plus sin square theta is equal to 1, if you remember, then cos square theta plus cos to the power root theta is also equal to how much? It is also equal to 1. Other result, if x is equal to a sec theta plus b tan theta and y is equal to a tan theta plus b sec theta, then x square minus y square, then x square minus y square will be equal to a square minus b square. This is another result. If x is equal to a sec theta plus b tan theta and y is equal to a tan theta plus b sec theta, then sin theta cos theta plus y by b sin theta is equal to 1, and x by a sin theta minus y by b cos theta is equal to 1. Then x square by a square plus y square by b square will be equal to 2. This is another important result which you must remember, that also you will get by just squaring on both sides and adding them. So we got these results, and with this we conclude the trigonometric ratios. Now coming to its applications. Let's come to applications of the trigonometry in finding the heights and distances. For finding the heights and distances, if we consider a building, this is a building and this is the ground. A person standing here is observing the top of the building. A person standing on the ground is observing the top of the building. Then the line along which he is seeing the top of the building is called line of sight. It is called line of sight, upwards. And the angle at which he is observing the top of the building, this angle is called angle of elevation. This angle with the ground horizontal, with the line of sight, is called angle of elevation. Then, if we go for a horizontal here, imaginary line is parallel to west, then this angle will be equal to this angle. At the same time, this is the ground and this is the building, this is the top of the building, and the man is observing from top of the building to something lying on the ground. A ball fell down from the top of the building and he is looking at the ball on the ground. Then, since he is looking from the top to the bottom, the line of sight, this becomes the line of sight. And the angle what he is making with the horizontal, this angle is called angle of depression. This angle is called angle of depression. Now again, angle of depression will be equal to this angle because these two are parallel and this becomes the transversal. The angle of depression will be equal to the angle of elevation. Angle of depression will be equal to angle of elevation with the line of sight. Now, how to find out the height and distances? Now, if this is the building, this is the ground, and the ball is lying here, let's name the building as AB, and the ball is at, let's have the ball here, B, and this is C, the foot of the building, the top of the building A, okay, this is the line of sight. Suppose the distance of the ball from the foot of the building is 20 meters, and the angle of depression is say 60 degrees. the angle of depression is 60 degrees, what we have observed, and the ball has fell down from 20 meters away from the foot of the building. Then, what is the height of the building? So you need to find the height of the building. So in that case, angle of depression is equal to angle of elevation. So we go for n triangle ABC. Tan 60 degree is equal to opposite by adjacent, that is h upon 20. And we know the value of tan 60, that is root 3, which is equal to h upon 20, or the h is equal to 20 root 3 meters. So that's the height of the building is 20 root 3 meters. So these values you can find out height, and in the same way you can find out the distance. We must know the values of tan 30 degree, which is equal to 1 by root 3, tan 60 degree, which is equal to root 3, and tan 45 degree equal to 1, which are most frequently occurring values in finding the heights and distances. Let's solve one question. If the string of a kite is 100 meters long and it makes an angle of 60 degrees with the horizontal, then find the height of the kite. The string of the kite is, suppose there is a kite here flying. This is the kite. Like the string is 100 meters and it is at a distance of, you are flying it from a distance. The string of a kite is 100 meters long and it makes an angle 60 degrees with the horizontal. It is making a 60 degree angle with the horizontal. Then we need to find out the height of the kite. How high the kite is flying. This is what you need to find out. Okay. Now, how are you going to find out? We don't know the distance, we know the length of the string of the kite. So in this case, let's name it A, B, and C. So in triangle ABC, we know the hypotenuse and we know the opposite. So it is h upon 100 is equal to opposite upon hypotenuse. It is the ratio is sine of what angle? 60 degree. So we get h upon 100 is equal to sine 60. We know the value is root 3 upon 2. So that implies h is equal to root 3 upon 2 into 100. That is 50 root 3 meter. This is the height of the kite from the ground.